So today we're going to go over the Unit 4 Section 3 notes, conditions for parallelograms. I had my students go ahead and grab a whiteboard, cloth, and a marker, and then we went through and answered these questions. So opposite angles are, you should know this, congruent. Diagonals bisect each other. Consecutive angles are supplementary. And opposite sides are, yes, we know they're parallel, but we know this is a parallelogram. So opposite sides are congruent again. So our objectives today are to prove that a given quadrilateral is a parallelogram. So you've learned to identify the properties of parallelograms. Now you'll be given the properties of a quadrilateral, and we'll have to tell if the quadrilateral is a parallelogram. To do this, you can use the definitions of a parallelogram or the conditions below. So the first one here, you notice it says if both pairs of opposite sides of a quadrilateral are parallel, then the quadrilateral is a parallelogram. So the statement we would write for that is that AB here is parallel to DC and BC is parallel to AD or DA. The next one says if both pairs of opposite sides of a quadrilateral are congruent, then the quadrilateral is a parallelogram. Notice here again we got QR is congruent with SP and QP is congruent with SR. And notice I'm continuing with my process of what we did with triangles and going from, like, if you notice here, acute to obtuse, so we would go from acute to obtuse there. Number 3 says if both pairs of opposite angles of a quadrilateral are congruent, then the quadrilateral is a parallelogram. Notice here we have that P is angle P is congruent to angle R, and angle Q is congruent to angle S. The fourth one says if an angle in a quadrilateral is supplementary to both of its consecutive angles, then the quadrilateral is a parallelogram. So that means when I add A to B, it would be 180, and when I add A to D, it would be 180. We have to have both of these now, not just one, but both. Number 5 is if one pair of opposite sides of a quadrilateral are both parallel and congruent, then the quadrilateral is a parallelogram. Now this one's new, not one that we've done before, so you guys need to really pay attention to this one. So here we say QR is parallel to SP. That's those arrows on there. And then we also say that QR is congruent with SP. So if both of those conditions, if they're both parallel and congruent, then we can say that this is a parallelogram. The last one is if the diagonals of a quadrilateral bisect each other, then the quadrilateral is a parallelogram. So we can see here that PT and RT are congruent, and QT and ST are congruent. So our first example says if JKLM is a parallelogram, find the value of A and B, then find the value of KJLM and KL and JM, and then say why is JKLM a parallelogram. So on this one, we should be able to see that we have some opposite sides here. So that's what we're going to test. We want to see if that pair of opposite sides is congruent, and we want to see if this pair of opposite sides is congruent, because then we could use that information to prove that this is a parallelogram. So we're going to set these two equations equal to each other here. And when we do that, we do 15a minus 11 equals 10a plus 4. Then we subtract 10a and we add 11. So we get 5a equals 15. We plug a back in. So kj would be 15 times 3 minus 11, that's 34. And with ml, it would be 10 times 3 plus 4 is 34. So now we can see that those opposite sides absolutely are congruent. Then we're going to solve for this other pair of sides here. Notice that we have 5b plus 6 and 8b minus 21. So here again, we're going to subtract 5 from 8, 5b from 8b, that's 3b, and we're going to add 21 to 6, that's 27, divide both sides by 3, that gives us 9. So we're going to plug 9 back up here in KL, so that'd be 5 times 9. Sorry, that's supposed to be plus 6. Fixed it, so it's 5 times 9 plus 6 is 51, and 8 times 9 minus 21 is 51. So again, we can see that those two pairs of opposite sides are the same measure, so they are congruent. So here we can say KJ is equal to ML, and KL is equal to ML. Now, what we need to do is we have to have this statement on our paper, and then we can say that quadrilateral JKLM is a parallelogram because both pairs of opposite sides are congruent. So our next one says, if ABCD is a parallelogram, find the value of x and y, and then find the measure of angle A, C, and B and D, okay? So here again, let's mark this first. So if these opposite angles are congruent, then it would be a parallelogram, right? That's our rule that we're looking at. So this is what we're actually looking for. Oh, I did that wrong. Sorry, y'all. And then these opposite angles would be congruent as well. So if those conditions are true, then we can prove that this is a parallelogram. So we're going to set, again, our equations, our opposite angles, A and C equal to each other. Then we're going to solve this by moving our 8x to the other side. Then we're going to factor that. And if you recall, what we're looking for are the factors of -9 that when added together give us -8. That would be a -9 and a 1, because when we multiply those together we get -9, but when we add them together we get -8. Then we would set those factors equal to 0, and that would give us 9 here and -1 there. Well, when I plug these back in for angle A, I can see that 8 times 9 is 72, and over here 8 times -1 is -8. We wouldn't have a negative angle measure, so we know the answer is not going to be a -1, so we can actually scratch through that answer because we know that that's not going to be true. And that means that this is 72 up here, and if that's 72, actually let me put that in a different color. Let's put that in red because that's what I did it in. So we're going to say this one is 72. And then we're going to plug that down there into angle C as well. And so that one would also be 72. Now we're going to set angles D and B equal to each other. And so we're doing 9y plus 9 equals 10y minus 2. We will subtract the 9 from the 10 and add the 2 to the 9. That would be 11. Or we're going to plug that 11 back into both of those equations. So 9 times 11 plus 9 is 108. And, 10 times 11 minus 2 is 108. So here again, we can see that those opposite angles are congruent, and we got to write that. Angle A is congruent to angle C, and angle D is congruent to angle B. And then, yes, ABCD is a parallelogram because both pairs of opposite angles are. Okay, let's look at example 3. It says, if PQRS is a parallelogram, find the value of x and y, and then find the measure of angle QR and S. So the first thing I notice is that I've got 3 angles here, and I've got R between Q and S. So I'm thinking I'm going to use that the consecutive angles of R are both supplementary. So, but to do first, to find that, we need to use something we know. So we do know that these 2 angles are congruent to each other. And so we're going to do that first. And then we'll see if we can find out if R is supplementary to those 2 angles. So I set those equal to each other. I'm going to solve for y. Y was 6.5. Then I'm going to plug it in to solve for Q and S. So when I plug it in for Q, I get 46. And when I plug it in for S, I get 46. So I got 46 both places here, 46 degrees there, and 46 degrees there. Now we got to find R. So to find R, we're going to subtract 46 from 180. That's going to give us 134. So that means we can set this equation up here equal to 134 because that's the measure of that angle, because again, they're supplementary because they are consecutive angles. So we then plug that equation in one side and the value of 134 in the other. We add 16 to both sides and we divide by 15. That gives us x is equal to 10. So this says, why is PQRS a parallelogram? Well, because when I add R to Q, I get 180, and when I add R to S, I get 180. So yes, PQRS is a parallelogram because both consecutive angles to angle R are supplementary. So number 4 says, if PQRS is a parallelogram, find the value of A and B, then find the measure of angle Q and R and QP and RS. So this time again, so actually let's look again at what we have. I'm going to actually look at this property up here first, that when I add these 2 angles together, they equal 180, because we're going to talk about that. That's what we really need to figure out, because what we need to find is that we need to determine if this is parallel with this. And if you recall, if QR is a transversal to the lines QP and RS, and QP and RS are parallel, those would be same side interior angles, because when we add them together, they're supplementary. And so we can then prove that those lines are parallel by the converse of same side interior angles. So what we're going to do is add them together and set them equal to 180. That would give us 19b, because 10 plus 9 is 19, and then subtract 16 from 25, that gives us 9. We're then going to subtract that 9 from both sides. That's going to give us 171. So B would be 9 when we divide both sides by 19. So we're now going to plug those values back in. So we get 74 for angle Q, and we get 108 for angle R. And when we add those two together, they do equal 180. So because the measure of R plus the measure of angle Q is 180, by the converse of same side interior angles theorem, we can say that QP is parallel to SR. So I'm going to put some parallel symbols on these sides. So the next thing we're going to check to see is, are these congruent? And we're going to find the value of A that makes that true. So when we do this, we're going to then set those equal to each other. We get that A is equal to 2.4. Then we're going to plug it in for QP over here, which will give us 16.8 for QP. And we're going to plug it in over here for RS. We get 16.8. So here we can see that QP is congruent to SR. So because one pair of sides is both parallel and congruent, we can say that yes, PQRS is a parallelogram, because one pair of opposite sides is both parallel and congruent. All right, number 5. So on number 5, we're going to use a property that has to do with the diagonals. And we know that if this is a parallelogram, then our diagonals bisect each other, which means they cut one another into equal or congruent parts. So we're going to set this up by setting AG equal to CG and solving this. We would subtract the 8x from the 10x. That would give us 2x. And then we would add 24 to 12, that's 36. And then when we divide 2 into 36, that would be 18. So now we're going to plug that value of x for 18 for x into AG and CG. So when we do that, we get 156 for AG, and we get 156 for CG. So that means that AG and CG are congruent. Then we're going to do this other one, DG and BG. So we set those equal to each other. 2y minus 80 equals y plus 9. This time we're just subtracting y from 2y, that gives us y. And then we're going to add 80 to 9, that gives us 89. Now we're going to plug that value back in for DG. So that's going to be 2 times 89 minus 80, which is 98. And then we're going to do 89 plus 9, which is 98 as well. That again tells us that AG is equal to CG and DG is equal to BG. So this does allow us to prove that these two are congruent, because ABCD is the diagonals bisect each other. All right, so let's look at number 6. It says, is this quadrilateral a parallelogram? If so, why? So notice here that 107 is a consecutive angle to 73, and 107 is a consecutive angle to 73. So we can add those together and get 180 for both of them. Thus, yes, it is a parallelogram, because both consecutive angles to the 73-degree angle are supplementary. Number 7, it says, is this quadrilateral parallelogram? If so. Well, the answer to this is no. We only have one pair of opposite angles that are congruent, so we can't prove that this is a parallelogram. On this one, it says, is the quadrilateral parallelogram? If so, why? Well, on this one, hopefully you guys can see that we can mark the third angle here and the third angle here. So once we do that, then we should be able to see that this angle is congruent with that angle. So we got one pair of opposite angles, and we have the one arcs that are congruent with each other as well. So we're going to say yes, the diagonals of the quadrilateral form two triangles, and two angles of one triangle are congruent to the other, so the third angle are congruent, and by the third angles theorem. So this is the part that you better write in on your paper. The third angles theorem is why we have that the third angles are congruent, And so both pairs of opposite angles of the quadrilateral are congruent, thus the quadrilateral is a parallelogram. On this one, number 9, we do have one pair of sides, opposite sides, that is both parallel and congruent. So this was our new rule. So yes, this one is a parallelogram. Number 10, notice here we have consecutive sides that are congruent, but we don't have opposite sides. So this one is no, because there's just consecutive sides and not opposite sides. This one is like the one we did before, only this time our third angle's over here. So once again, by the third angles theorem, we can prove that the opposite angles are congruent. And notice here again that we could have said that this angle and this angle are congruent, and those are opposite angles. So recall again that you better be writing the third angles theorem as the reason why you said that those third angles were congruent. And they are, it's a parallelogram because both pairs of opposite angles are congruent. Number 12, is the quadrilateral parallelogram? If so, why? So hopefully you can see here that our diagonals are bisecting each other. We got this part is congruent with this other part. And then we've got 2 ticks here and 2 ticks there. So we can see that the diagonals do bisect each other. So the quadrilateral is a parallelogram. This last one was not in your notes, but I'm going to go over it anyway. So on this one, the answer is going to be no. We would have to have both pairs of opposite sides being congruent or both pairs of opposite sides being parallel, and that is not the case. So this one is not congruent. Now these are all the rules that we learned, right here. So remember, conditions for parallelograms. Both pairs of opposite sides are parallel. One pair of opposite sides are parallel and congruent. Both pairs of opposite sides are congruent. Both pairs of opposite angles are congruent. One angle is supplementary to both of its consecutive angles, and the diagonals bisect each other. Those are all the rules that we went over today that prove that two quadrilaterals are parallelograms.